Waiting to buy a home? The Churchill Mortgage team says now is a great time to buy. Waiting could be a costly mistake because when rates drop, new home buyers will flood the market, driving up home prices. Go to churchillmortgage.com for your free analysis and see how home values can outpace rates to help you build wealth over time faster. This is a paid advertisement. NMLS ID 1591. NMLSconsumeraccess.org. Equal housing lender. 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee to its signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
This is SpaceTime, Series 24, Episode 67, for broadcast on the 14th of June 2021. Coming up on SpaceTime, Abbot Point selected for Australia's next orbital launch facility, strange ongoings in our planet's interior, and OSIRIS Rex finally heading back home. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Abbot Point in North Queensland has been selected to host Gilmour Space Technologies' new orbital launch complex. The location next to the existing port facility and the nearby town of Bowen will allow equatorial launches to the east over the Whitsundays and Pacific Ocean on a range of inclinations and orbital altitudes. Because of planet Earth's rotation, rockets launching to the east from near the equator get an additional boost in speed as the Earth spins, and this allows them to launch more payload for the same amount of fuel. Confirmation of Abbot Point as Australia's next orbital launch facility follows a $400,000 feasibility and technical study. The investigation found potential environmental impacts would be manageable, and the drop zones for jettison rocket stages would be outside the Great Barrier Reef World Heritage Area. The complex would include a launch pad, vehicle assembly building, fueling systems and storage facilities, a launch control centre, as well as communications and meteorological services. Developing a launch site at Abbot Point would also deliver a huge economic boost to the region, creating hundreds of new jobs. The first flights of Gilmour's Ares rocket are expected to take place next year, with the Space Machines Company's Space Taxi and Fireball International's Fire Detection Satellite being the first launch customers. The company's already undertaken an extended series of successful tests of its new hybrid rocket engine. Head of Launch Operations James Gilmour says the company is also looking at a second launch facility, this one for polar launches, most likely in South Australia. Another company, Southern Launch, is already planning a polar orbital launch facility at Whalers Way near Port Lincoln on the Eyre Peninsula. Gilmour says it's part of the company's All Orbits, All Planets vision, which will see sovereign space capability launching Australian-made rockets with Australian payloads from an Australian launch site.
We're proposing a facility to support light launches, which essentially gives us access to multiple low Earth trajectories. It's located within the Abbot Point State Development Area within the Whitsundays Regional Council, so in tropical North Queensland.
So this is what, somewhere near the coal loader or that sort of area?
It's actually, yeah, exactly. So it's just south of the Abbot Point terminal, and it's about 15 kilometres north of the Bowen Township.
Okay, and what sort of rockets will we be flying from there?
Well, so rockets such as ours, which is called OSIRIS, and essentially that's a 23-metre vehicle, and fully fueled that will weigh about 33 tonnes. That will deliver payloads to low Earth orbit.
How big will those payloads be?
Well, initially they'll be around 250 kilograms. And what is really exciting is that on our first vehicle, we'll be launching 2 Australian-based payloads or customers. So this will be a significant demonstration of the sovereign space capability, an Australian launch vehicle from an Australian launch facility, launching Australian payloads facilitated by Australians. Can't get a better story than that.
Why was the site selected? Why not go further north towards Cape York, where you're closer to the equator, so you get more of a boost from the Earth's spin?
Of course, that is a major consideration, but there there are a number of considerations that determine the suitability of a launch site. So access to critical infrastructure, that's a big one, but also range safety is probably the biggest considerations. So any further north and you start potentially impacting our dear friends in the Solomon Islands. So our first launch angle will be about 34 degrees, and that's well away from the Solomon and Vanuatu Islands. Other considerations, your access to people. You want people to be able to live near the area as well, and the Bowen Township is extremely suitable for an activity such as that. And also you have to be away from sensitive receptors where the Abbot Point does present an extremely suitable area for a proposed development such as this.
What about Equatorial Launch Australia in the Northern Territory, Southern Launch in the Eyre Peninsula? Would it be an idea to sort of combine resources?
Great questions. I think ELA is very suitable for a suborbital. I haven't seen too much info regarding the orbital mechanics or potentially some of the issues being in that location, launching equatorial and therefore affecting some of our northern tips of Australia and our northern neighbours. Now, Southern Launch is perfect. We're looking to work with them. We're looking to stand up an agreement shortly, but they can only handle polar or
launches, yeah.
So we need something that's complementary. So we see Abbot Point combined with Whalers Way to be a huge opportunity for us to deliver on our vision, and that's essentially to enable access to all orbits, all planets, for the advancement of humanity.
What we're seeing with Electron from Rocket Labs in New Zealand is a really high launch frequency. There seems to be a big business out there for a small payload capability.
Definitely. There is just not enough supply to fill that demand. So they're a great company. They're the second essentially commercial organization to offer launches. SpaceX is obviously the market leader on that, but we're looking to make a really big impact on that. Our choice of technology is that of the hybrid. We're on track delivering a very safe and reliable and cost-effective solution to the thousands of customers that need access to specific orbits. So we're really excited and really bullish.
Tell me about the hybrid engine as it now stands that you'll be using.
So we don't have a name for that, but we're taglining it as main engine Thunder, because when we actually tested it once, it did bring the Thunder. And essentially that's about 120 kilonewton single port hybrid rocket engine. And so quite substantial. And that will essentially make up, there'll be 4 of those engines on the first stage, and that will propel the vehicle. Hybrid rockets are extremely unique. They have throttling capability and other particular characteristics like safety, minimal environmental impacts, i.e. being a green propellant, lower life cycle costs, responsiveness. So we're really excited about the potential that this can have, not just domestically, but abroad.
The hybrid engine, in your case, it's what? Pellets being used as the solid fuel and then an oxidizer? Is that the plan?
Yep. So we put the hydrogen peroxide through a catalyst, and then that combusts with the solid fuel grain. And essentially, we can throttle by varying the oxidizer mass flow rate. So a really exciting technology, and it's developed right here in Australia.
And you've been able to check it to make sure it throttles up and down as needed to meet max Q requirements and things like this?
Of course. The systems are actually very sophisticated, particularly the engine management systems and also the flight computer. We're trying to do as much as we can with working with commercial off-the-shelf components. The G&T team and the software and avionics are doing a great job to develop a capability that's in line with the technology roadmap. And some of those leading individuals are actually Australian. So this is great.
What's your timeline for the first launch at this stage?
As per the system engineering project plan, we're probably looking at about mid next year. So launch countdown has been activated, and we're really happy with this recent announcement from the state government to greenlight Abbot Point for our proposed launch facility. And so we're going to do whatever we can to make sure that we deliver this capability mid next year.
And what sort of facility will you actually be building there? There'll be a hard stand, there'll be a strong back.
Yep, essentially some of the key requirements are the vehicle assembly building. That will be a small facility where we'll bring in the vehicle to reintegrate the vehicle and integrate the payload. And then the other significant requirement is the launch pad. We'll have the propellants and oxidizers and gases that are required to facilitate the launch. And then there'll be fluid storage and utilities area. And then there'll also be a launch control that will be situated near the launch site. So minimal viable product, but all very achievable in the time frame that lays ahead of us.
And that's Head of Launch Operations, James Gilmour. And this is SpaceTime. Still to come, is the Earth's core lopsided? The strange goings-on in our planet's interior. And OSIRIS Rex says bon voyage to Bennu as it heads for home. All that and more still to come on SpaceTime.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee due at signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
A new study claims Earth's solid inner core is solidifying faster on one side than the other. The findings, reported in the journal Nature Geoscience, also shows that the process has been going on ever since it first started to freeze out from the molten iron more than 500 million years ago. But interestingly, the faster growth, which is taking place under Indonesia's Banda Sea, hasn't left the core lopsided. That's because the planet's immense gravity evenly distributes the new growth of iron crystals to maintain a spherical inner core that grows in radius by an average of 1 millimetre per year. But the enhanced growth on one side suggests that there's something in Earth's outer core or mantle, something under Indonesia, that's removing heat from the inner core at a faster rate than on the opposite side under Brazil. Quicker cooling on one side would accelerate iron crystallization and inner core growth on that side. And this all has implications for Earth's magnetic field and its history, because convection in the outer core, driven by heat from the inner core, is one of the things driving the geodynamo, which generates the magnetic field that protects the Earth from the solar wind streaming out from the Sun, as well as cosmic rays from deep space. One of the study's authors, Barbara Romanovich from the University of California, Berkeley, says the findings also help provide a rather loose boundary on the age of the inner core, placing it between 500 million and 1.5 billion years. And that can help in the debate about how the magnetic field was generated prior to the existence of the solid inner core. Previous studies have already shown that the magnetic field already existed 3 billion years ago, so other processes must have driven convection in the outer core at that time. The youngish age of the inner core could mean that early in Earth's history, the heat boiling the fluid came from lighter elements separating out from iron, rather than from the crystallization of the iron seen today. Asymmetric growth of the inner core also explains a 3-decade-old mystery, that the crystallized iron in the core seems to be preferentially aligned along the rotational axis of the Earth more so in the west than the east, whereas one would expect the crystals to be randomly oriented. Evidence for this alignment comes from measurements of the travel time of seismic waves from earthquakes through the Earth's core. Seismic waves travel faster in the north-south rotational axis than along the equator, an asymmetry that geologists attribute to iron crystals which are asymmetric, having their long axes preferentially aligned along Earth's axis. If the core is solid crystalline iron, then how do iron crystals get oriented preferentially in one direction? In an attempt to explain the observations, scientists created a computer model of crystal growth in the inner core, which incorporates geodynamic growth models and the mineral physics of iron at high pressures and temperatures. The simplest model seemed a bit unusual, namely that the inner core is asymmetric, with the west side looking different from the east side all the way to the centre, not just at the top of the inner core as some have suggested. The only way scientists can explain that is by one side growing faster than the other. The model describes how asymmetric growth, about 60% higher in the east than in the west, can preferentially orient iron crystals along the rotational axis with more alignment in the west than the east, and explain the difference in seismic wave velocities across the inner core. Planet Earth's interior is layered like an onion. The solid iron nickel inner core is about 1,200 kilometres in radius. That's about 3/4 the size of the Moon. Now, it's surrounded by a fluid outer core of molten iron and nickel that's about 2,400 kilometres thick. The outer core, in turn, is surrounded by a mantle of hot rock some 2,900 kilometres thick, and that's topped by a thin, cool, rocky crust on the surface. Convection occurs both in the outer core, which slowly boils as heat from the crystallizing iron comes out of the inner core, and in the mantle, as hotter rocks slowly move upwards, carrying this heat from the centre of the planet to the surface. The vigorous boiling motion in the liquid iron outer core, combined with the Earth's rotation, produces Earth's magnetic field. Now, according to the author's computer model, as the iron crystals grow, gravity quickly redistributes the excess growth in the east towards the west within the inner core. Now, that movement of crystals within the rather soft solid of the inner core, which is close to the melting point of iron at these high pressures, aligns the crystal lattice along the rotational axis of the Earth to a greater degree in the west than in the east. The model correctly predicts the researchers' new observations about seismic wave travel times through the inner core. The anisotropy, or difference in travel times parallel and perpendicular to the rotational axis, increases with depth, and the strongest anisotropy is offset to the west of Earth's rotational axis by about 400 kilometres. The model of inner core growth has also provided limits on the proportion of nickel to iron at the centre of the Earth. It wouldn't accurately reproduce seismic observations unless nickel makes up only about 4 to 8% of the inner core, which is actually close to the proportion found in metallic meteorites, which are presumed to have originally been the cause of differentiated dwarf planets in our solar system. This is SpaceTime. Still to come, OSIRIS Rex heading for home following its sample return mission to the asteroid Bennu, and China launches the first of a new generation of weather satellites. All that and more still to come on SpaceTime. NASA's OSIRIS Rex spacecraft is now on its way back home to Earth, following its smooth on-course departure from the potentially hazardous near-Earth asteroid Bennu. Mission engineers had been planning to undertake a small thruster firing to ensure the spacecraft stays on the correct path back to Earth. But the 7-minute full-throttle engine burn departure manoeuvre on May the 10th, timed to match the alignment of Bennu with the Earth, was calculated and executed so precisely, mission managers have decided not to undertake a cleanup manoeuvre at this stage. The spacecraft's course is being primarily determined by the Sun's gravity, but small course corrections will be made during the journey using engine burns. The next possible course manoeuvre adjustment is likely to occur in 2022. Right now, the probe's already moved some 528,000 kilometres from Bennu. The 492-metre-wide space rock 10-1955 Bennu is what's known as a Type B carbonaceous Apollo group asteroid. That means it's a NEO or near-Earth object, and its orbit intersects with and crosses Earth's orbit. But Bennu's orbit is also intrinsically dynamically unstable, and astronomers say that gives it a 1 in 2,700 chance of impacting the Earth sometime between 2175 and 2199. Launched from Cape Canaveral in September 2016, the 2,110-kilogram OSIRIS Rex spacecraft arrived at Bennu in October 2018, spending 3 years orbiting the asteroid at altitudes as low as 5 kilometers, mapping Bennu's surface and geology, studying its evolution, composition, chemistry, and mineralogy. One of the mission's key objectives was understanding non-gravitational influences such as the Joukowsky effect, in which sunlight heats up the surface of an asteroid. That heat is then radiated back out into space, providing a small amount of thrust as the asteroid rotates. Knowing Bennu's physical properties and how that will be affected by the Joukowsky effect is critical for astronomers trying to determine the likelihood of the asteroid colliding with Earth. As part of that aim, in July 2020, OSIRIS Rex used a robotic arm to collect 60 grams of regolith from the asteroid's surface. The 2.5-year cruise phase back to Earth will see OSIRIS Rex swoop to within 10,000 kilometres of Earth in September 2023. As it approaches the planet, the spacecraft will jettison its sample return capsule. That'll parachute down onto the test and training range in Utah's West Desert on September the 24th. OSIRIS Rex still has plenty of fuel remaining. Mission managers are hoping to preserve as much of that fuel as possible in order to use the spacecraft for a potential extended mission to another asteroid. We'll keep you informed. This is SpaceTime. Still to come, China launches the first of a new generation of meteorological satellites, and later in the science report, Australia's largest dinosaur, a new species of sauropod, unearthed in southwestern Queensland. All that and much more still to come on SpaceTime.
See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.
China has sent the first of a new generation of meteorological satellites into geostationary orbit. The Fengyun 4B was launched aboard a Long March 3B rocket from the Xichang Satellite Launch Center in southwestern China's Sichuan province. Beijing says the new spacecraft will be used both for weather analysis and forecasting, as well as environmental and disaster monitoring, suggesting a broader role than just meteorology. The Fengyun 4B was placed into a 35,786 km high geostationary orbit, where it will complement and eventually replace the earlier Fengyun 4A satellite, which was launched back in December 2016. The 5,400 kg Fengyun 4B will have a longer 7-year service life with improved observing capabilities compared to the earlier Fengyun 4A, which is expected to run out of fuel sometime this year. Fengyun 4B science instrumentation package includes a geostationary interferometric infrared sounder and a radiation imager, as well as a space environments package for sensing high, medium, low energy particles, an imaging telescope for X-ray to extreme ultraviolet activity monitoring, a geostationary high-speed imager, and a lightning mapper. The mission was the 372nd flight of a Long March series rocket. This is SpaceTime. And time now to take a brief look on some of the other stories making news in science this week with a science report. A new study warns oxygen levels in the deep waters of lakes around the world have declined by an average of 18%. The research, reported in the journal Nature, analysed some 400 lakes, finding the loss of dissolved oxygen seriously affects the health of the lakes and could lead to global declines in biodiversity. The authors found human activity and warming temperatures caused oxygen levels to decline over time and suggest lake ecosystems need more rigorous management. Paleontologists have described Australia's largest dinosaur, a new species of sauropod unearthed in what is now southwestern Queensland. The fossilised remains of the 30-metre-long Australotitan cooperensis, or southern titan from the Cooper, were first discovered in 2004. Scientists spent the next 17 years painstakingly uncovering and describing the giant herbivore, which roamed what were once forests and grasslands during the Cretaceous period between 92 and 96 million years ago. A report in the journal PeerJ claims Australotitan cooperensis is just the tip of the iceberg, with evidence of numerous other dinosaur fossils scattered around the dig site. United Airlines have signed up to purchase an initial 15 supersonic airliners from aerospace startup company Boom. The new aircraft, known as the Overture, is slated to begin flying in 2029. The 55-seat Delta Wing 3 engine aircraft will be a smaller version of Concorde, constructed out of composite materials and have a range of 8,300 kilometres and a top speed of more than Mach 1.7. Predicted journey times could see New York to London in 3.5 hours, and San Francisco to Tokyo in 6 hours. As for its predecessor, Concorde began passenger services in 1976, carrying 120 passengers at more than Mach 2, twice the speed of sound. The iconic supersonic transport was retired in 2003. Well, it seems Microsoft has been kowtowing to the Chinese Communist Party, obediently censoring its Bing search engine's iconic image of a lone man blocking a row of People's Liberation Army tanks during the time of the 1989 Tiananmen Square massacre. The famous Tank Man photo, as it's called, was taken on June 5, 1989 by Jeff Wiedner from Associated Press. A Bing search for Tank Man yielded no results, yet an identical search on Google produced hundreds of the iconic moment. The horrific Tiananmen Square massacre, which happened 32 years ago this month, saw hundreds, possibly thousands of democracy freedom protesters killed by the Chinese military. Many were shot at point-blank range. But the exact number of dead is unknown, as many of the dead and injured were repeatedly run over by tanks and armoured personnel carriers. It's widely believed that Microsoft have been censoring its content at the behest of the Chinese government for many years. There seems to be a real problem somewhere in the University of Wollongong. Universities are meant to be places of learning, where science facts reign supreme. But not the University of Wollongong. They're already notorious as a winner of an Australian Skeptics Spent Spoon Award for the most preposterous piece of paranormal or pseudoscientific piffle after awarding a PhD for, of all things, an anti-vax thesis. Now, as Tim Mendham from Australian Skeptics reveals, Wollongong University was planning to introduce a course on dowsing, water divining, using what the university was describing as Earth's invisible energies.
This story's in two parts, okay? Obviously, the University of Wollongong has a bit of a history with the skeptics because they gave a PhD on vaccination policy and are supposedly pointing out all the issues, including world conspiracies and this sort of stuff. It was full of the most ridiculous comments, and some of them were wrong and all sorts of things. We've done a big study of this PhD. This was issued a number of years ago. It caused a fuss in the scientific community because you're thinking it downgrades all the other PhDs that have been issued by the University of Wollongong. We're saying if this one can get through...
Totally worthless.
Not about worthless, but certainly they'd be upset, and the university is not very keen to actually take this PhD away, and we've actually asked them. Anyway, for that reason, they don't want to sort of debase all the other PhDs they've got, although that could already have happened. Right. Recently, the university has these sort of school holiday weekend courses for kids. A lot of universities allow different groups onto their premises to do different courses. You can probably get how to play bridge on a weekend course or something like that. Even among some fairly sciencey sort of fun things for kids to do, hands-on science things, there was one program for teaching kids how to do dowsing or water divining. And it was full of the most ridiculous pseudoscience about together we will be able to find Earth energies and objects we cannot see using dowsing. Dowsing is an ancient technique used to find things and solve problems. We will be using a pendulum and some L rods, which is the bent wire bits, to locate objects and spots of energy. No special power needed as the dowsing instruments respond to electromagnetic stuff we cannot see. There is a technical term for that, which is BS, of the worst order. And this is actually on a University of Wollongong program. It's got University of Wollongong branding all over it.
And this is definitely something which can't be confused with a Harry Potter movie or something like that, a deliberate bit of pantomime for kids.
No, the interesting thing is they're also having courses there about Harry Potter, but looking at mythical creatures and that sort of stuff, which is fine. Okay? No problem with looking at mythical creatures. There'd be no problem if actually if they were doing a dowsing and say, does this work, right? That'd be a different thing, although I dare say most kids in year 3 and 4 were not that fascinated by seeing if dowsing works, but this says implicitly dowsing works and it finds electromagnetic stuff, which is, it's rubbish. But the interesting thing is we ran this story in our newsletter saying this is what's going on at Wollongong and suggesting perhaps they're going for another Bent Spoon nomination. A lot of people complained to the university, and with one day the course was cancelled, so it's gone. And I think they either realised that, oh my God, here we go again. Here we go again, and they cancelled it within one day. We're trying to find out the background of the person who was putting on the course.
Yeah, I think that's the interesting thing. That happens a lot, doesn't it, where the entire university is getting blamed, and it's usually just one or two people who are really behind it all, and they're the ones who really need to be looking for a more suitable career.
Sometimes you get the situation where, as I said, some of these little groups put on courses over a holiday period or something like that, sort of one day a week for 7 weeks or over a weekend or something like that. And some of them are dodgy. They're actually learn to talk to spirits, that sort of stuff. Most of them are inane, pretty straightforward, fun things to do, history of this, etc. As I said, playing bridge. But there is the occasional one that sort of sneaks through. Now, most of these are not done by the universities. They're done by outside groups, and they're just sort of gathering in university premises to put them on. This was a university thing. This was actually done by the University of Wollongong. And I was just surprised that they allowed that through. I think, really? And it might be done by a bit of a fringe group within the university, but it was very weird. It was very weird indeed. But the effect was mass skeptics action implemented quickly had an impact. It's only a little thing. It's not the end of the world, but it indicates something about the University of Wollongong that they should be aware of.
And just like that, it was gone.
Just like that. Poof.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTimeWithStuartGary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.